Hi, welcome to like the 150th video of the final solution, or solutions to the final exam for Algebra 2 for first semester. Okay, I'm going to start at number 47 and I'm going to get through 50. A couple of these problems have a couple parts. But if you have your sheet in front of you, you can see the whole problem. State how many solutions a quadratic equation given the discriminant has values of. Now, first of all, on your note sheet, make sure you know what the discriminant is. Discriminant is part of the quadratic formula. If you remember that, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Use that to find the solutions to a quadratic equation. If the value underneath the radical is positive, negative, or 0, it will determine the number of solutions. So that's why they call that the discriminant. So just b squared minus 4ac. Now, if it's a positive number, you'll get two different values, because when you add or subtract a positive number, you get two different possibilities, and they'll be real. If it's 0, plus or minus 0 will give you the same answer either way, so you have one solution. If it is negative, when you take square root of a negative, it'll be an imaginary number, and so it'll have no real solutions, but two imaginary solutions. So let's look at these. For A, it's negative, so that means no real solutions, two imaginary or complex. Remember, complex is a combination of real and imaginary numbers. Part B, if your discriminant is 25, you'll have two real solutions because it's positive. If your discriminant is 0, well, square root of 0 is 0. Adding or subtracting 0 gives you the same answer. So you have one real solution. Okay, so make sure you have the discriminant on your note sheet. Quadratic formula is always good. Don't be humming the song during the test. That just annoys your neighbors. Okay, what value of c makes the expression x squared minus 16x plus c a perfect square? A perfect square trinomial. Make sure you have this process on your note sheet. Define the value c that makes it a perfect square. If you remember, we took the middle term, divided it by 2, and then squared it. And that's what c would have to be. Negative 16 divided by 2 is negative 8. Negative 8 squared is 64. So c would have to be 64. So make sure you have something about that on your note sheet. Okay, 49. Rational exponents. Write x to the 3/4 in rational notation. Remember, the numerator will be your exponent, and the denominator is going to be your root. Okay, it's going to go in there. So x to the 3/4, you can write it as x to the 3rd, and take the 4th root of x to the 3rd. Or you could actually do this. The 4th root of x, all that to the 3rd power. Either way works. It means exactly the same thing. Alright, number 50. This is an annoying problem. First thing we need to do is take that rational exponent and write it in radical form. So the 3rd root of 375 plus the 3rd root of 3. Now, 3rd root of 3, we can't simplify that because square root of 3, there's no perfect squares to take out. But 375, if you sit down and do the math, you find out 375 is 5 times 5 times 5 times 3. Okay, I'll put plus 3 squared. Hey, 5 times 5 times 5. Since I'm taking 3rd root, I need 3 5s to bring it outside. So these 5s come outside and make that 3rd root of 375 equal to 5 times the 3rd root of 3. Now check this out. We end with 5 times the 3rd root of 3 plus 3 times the square root of 3. This is actually your answer. You can't combine them because this is a square root and that's a 3rd root. The roots have to be, the indexes or the roots have to be exactly the same in order to combine them. Right? So that problem is done right there. B. I like this problem much better. The 5th root of 32, x to the 5th, y to the 10th. You can do the short way or the long way. 32. Well, that's 2 to the 5th. 2 times 2 times 2 times 2 times 2. Okay. It takes 5 2's multiplied together to make 32. Then x to the 5th and y to the 10th. I can write that as y to the 5th times y to the 5th to make things easier. Yeah, I know there's a shortcut. Anyway, 2 to the 5th, when I take the 5th root, or you can think of it as I need 5 2's to come out to make 1 2 outside. They'll come outside and I have 2. And then x to the 5th, that comes out as an x. And y to the 5th and y to the 5th come out from underneath the 5th root, become y and y. There's nothing left underneath the radical, so that goes away. So your final answer is 2x y squared. All right, that's up through number 50. I'll do another video for the next group. Good luck. Make a nice note sheet. Have a good weekend.